a second. Wait. Oh, you pushed the button. I wanted
Oh,
to
yeah.
take. Yeah. Okay.
We are live, and we are talking about open source blockchain explorers for the 17th time. Yeah.
Yeah.
Oh no, I have a window
Feedback loop.
open with this thing, but yeah. So here we have just a nice little cozy call with Tomas and I. Oh, what's that, Tomas?
The same thing that you have actually.
Oh,
The
that's
Burning Man.
epic.
Anyway.
Yeah, that's right. Did you get one of these this year?
Yeah. Yeah. See, this is the same thing.
Oh yeah. Well, that's much cooler.
Never mind. Open source blockchain explorer
Oh yeah,
17th
that's
time.
right.
That's what you were
Right.
talking about. We're
You
live.
can always distract me with Burning Man. I'm pretty easily distracted. But yeah, no, it's just you and me, man. We're just in chat, so it's nice and easy. You know, we can keep it cash.
No, you're breaking up.
Oh no, my internet sucks apparently as well. But yeah, either way, we love Etherscan, and but it's a golden cage, and there's lots of cool people doing lots of cool things, and Tomas is definitely one of them. Tomas, what are you working on, man?
All right, so yeah, like we all love Etherscan, like you said, and a month and a half ago, I was this metadata catalog where you could get all the information about tokens. This if you're starting your own blockchain explorer that is open source, or just any site that requires any kind of information about what the contract represents, like what is the team behind the contract, what's the link, like it would be nice to have. And since that time, like updating, it moved forward. So we merged two databases there, and we have like information about 1,200 tokens that is on MIT license and one can use. Although it's kind of, I didn't merge the commits, so you have to dig through the GitHub to get that. Because I was sitting and looking at that list of catalog of tokens, and I'm thinking, oh, I would love to see also have a link that is to open source, like to sources of these contracts, right? Or any kind of additional information, like analyzing the contracts, how they are connected or whatever. And I said, like, how hard can it be to actually, like, okay, Etherscan has it. It has an API that, by the way, if Etherscan is watching, like, it doesn't deliver right source code for any analytics. But like I said, damn it, how hard it can be to like write a decompiler. It's bytes here, right? And you just sit there and you change that to the original. Like, so I sat down, I opened my favorite CryptoKitties contract, like launched the bytecode, and I said, all right, let's get it going, right? And after a month of crunch time, like it began to look like actually something that someone might use, and there is a link in the comments to the tool. But I think I managed to build a decompiler that delivers kind of almost bug-free sources that are, I think, sometimes even as readable as the original, even if not better in certain cases. So that's quite cool. And yeah, like I could talk as much as you want about the whole idea because my friends are already bored with that. Like I kept telling them.
Please, I mean,
that.
Keep going, and maybe you could even. I don't know if you want to. I don't know if you want to demo it if it's
Oh
live.
yeah, I can if it's it's live. So let me just close all the other tabs, although I don't have anything embarrassing here, fortunately. All right, let's
right on the screen.
Yeah. All right, screen share, let's do it. Let's try application window, Google Hangouts.
Yeah.
Or okay. Okay. So the cool you can see it load. All right. So the site was kind of rushed. I did that one night before DEF CON. So at 10 p.m. I wrote a whole server to host it. But the idea is quite simple, right? So you go to the website, you click show source code. and it shows you the source code. And like, this is one of the coolest things I ever built in my life. So for any contract that you have, even if it doesn't have sources from Etherscan, wherever, you can see something that is, okay, it's not Solidity, it's more Python style. I really dislike curly brackets, but you can actually understand what the contract does. And this is, it has some bugs, but in general, like, it's kind of, it's readable, and you can actually understand, well, essentially for any single contract on the blockchain, and actually decompiled like over 1 million of them by now, and just and there is a cool button that
there's a contract I've always wanted to check out. Can I find it? I don't know. Maybe you can help me find. I really want to find the DAO hacker contract.
Let's do it. Let's do it live. All right, that sounds fun. Can you send me the link? I can type it because I have screen share enabled already.
It might take me a second to find it.
Yeah, we were talking on, okay, and I will connect to electricity in the meantime. So I can continue talking about the compiler, and there are so many things that I'm super proud of in it. That just it was like okay. Let me connect to electricity first. Okay, you can keep looking, and I can keep talking. Like the idea is to have this decompiler open for anyone. And actually, right now I have all the sources decompiled of all the contracts. So if anyone wants to use that in their own blockchain explorer, I can just send them one big as zip file that is a few hundred megabytes, I think. So you can have an alternative to Etherscan's show sources, and that's one thing. The second thing is that I plan to open source the whole thing, but just I need to polish the sources a little bit, and I want to play with that. And okay, I'm waiting for you to deliver the address so we can see how it works. Or
yeah, well, how long did it take you to do this? I can't believe it was so short.
It was like a month to a month and a half. That was like quite crazy work, but around that time, because the last time we were on a call, I think like a few days before. That was September. No, it was a month and a half. So like a month later, I started working on that. So I got that delivered in a month and a half. It still has some bugs though. Like some functions it doesn't process correctly, and it has tiny features. So I would lie on a stake here, saying that it's 100% correct, but for many things it is. And I had already people use it to decompile some of the sources that they couldn't analyze any other way, or just had difficult time analyzing in another way. So yeah. Do you have it? I can try Googling it.
You know, I tried finding it on Etherscan, but it doesn't show it because it's too far back and there's too many transactions. So I'm gonna try finding it. Yeah, let's both Google it, because this will be. Okay. I really want to know what they did.
Okay, let's.
I know what the White Hat group did, and I'm wondering how close it is. You know.
Yeah. Contract address. We can try Bloxy.
What's Eamon Gunsur's like IC3? I'm sure it's on that article where he explained how the DAO hack happened. Do you know what the name of his it's like hacker or something?
Nah, I didn't remember.
Let's see. Maybe I'll just search for Eamon. Hacking distributed, that's what it is. So how do you It's amazing. I mean, you're just running bytecode, and that's
Okay,
how
so I can tell you more about how it's being done. Like, there are two methods to do decompilers, and the one that I use, I think, is kind of unusual. I think no one else tried that, for at least for EVM, because the regular method is you just look at the source code and then you split it into smaller parts and whatnot. Let me just turn off screen share for a while, for a moment. Okay, so usually you look at you try to split source code into smaller pieces and the way I do it is I essentially build a whole EVM, but I like in-house, but I don't use arithmetic. I just use symbols or with arithmetic. So like the regular EVM, when you run a function, you get a parameter there, right? That it, like the EVM knows that this is parameter 5, and it uses it for something. Like it's a concrete value, right?
Yeah.
And it just runs the code. So in my case, if I see some kind of a parameter, I don't know what parameter it is. So when the EVM says, oh, like push this parameter on the stack or do whatever with that, I just push on stack information that this is, I don't know, parameter from function call, or this is something from storage that I don't know because it's symbolic. It's not known at the given moment, right? So
Yeah.
I have the whole EVM that is running on basically algebra or on symbols instead of arithmetic values. So it's like essentially all the operations included there. And then there is a lot of math to solve some of the things. And like one of the cool things is, for example, I don't know how precise to be, but let's say that you have let's say that you want to put something in the memory, right?
Mm-hmm.
And with regular EVM, that's a simple operation, right? You have a command that tells you, all right, put something here on the memory position this and this, right? That's easy. But then if you have symbols, you sometimes will have an operation that says, oh, put this some unknown value to a memory that's positioned on this other unknown value. And then you have to have the whole memory model that doesn't really have any concrete locations. It just can use mathematical equations to figure out what is where in the memory. And then you have to kind of figure out how to read from that memory. So that was a lot of work to figure out how to do that. And yeah, I don't know what's more to say here. But focusing, like thinking about decompiling this, but I can try decompiling something else and just show some quirks of it and how it works exactly. That may be interesting.
Yeah, that would be cool.
Okay. Okay, so for example, this is CryptoKitties contract, and I absolutely love CryptoKitties for one reason when it comes to the contract, that it has all kinds of weird scenarios there. So it has loops, it has like most of the contracts that you can see in EVM, like you will see in one way or another in CryptoKitties. So if you are able to compare this one, like you're halfway there to building a proper decompiler. And like for most of the functions, like I can process them quite nicely, right? So you can see almost like Solidity style kind of code. Now, like with some of the functions, it even takes parameters from like parameter names from the function description. Still has some quirks, meaning like with some of the functions, I cannot figure out some of the loops. So this is one of the things. And then I have to show all the memory operations on the way, and like I dislike this function. So this one, token metadata, I had sleepless nights trying to figure out how to make this look better, and I'm quite sure I can get it. Like there are still some quirks, but I can do it. And you know, like there is a lot of talk about the new EVM, how it's how what new opcodes should be and new languages. And I think like actually, like when we talk about analysis, just somehow getting rid of these loops, that would be nice if we had some opcodes that handle that. And then for some other functions, like one problem, and right now I'm working on that. Like I've been doing that for the past 2 or 3 days. I call them spaghetti functions because it's like it has a lot of stuff that kind of gets repeated a few times, and I need to grab these things together and just make some other construct. So like that's another problem with this decompiler compared to original source codes, that some of the functions turn out like extremely long and it's hard to understand what's going on. But this is, I hope it can be solved soon. So let's see some random contract.
Yeah, so I sent you, I think this is the DAO hacker, one of the
okay.
DAO hacker contracts.
Okay, let's, did you send it to me on Telegram or?
Oh no, I sent it in the chat.
Hangouts.
Yeah, I can send it to you on Telegram.
Okay, I don't know, Hangouts will be good. Oh, by the way, like, okay, I will click that in a second. I will just show you. I clicked random, and it's truly random. Like, it's not like I prefer some like some better or worse contracts to display when it clicks random. So just some random token that is there, and you can see it decompiled. Essentially, you can read what's going on in this contract.
Yeah.
It's like it doesn't matter. You know, this is like you almost cannot get more concise than this. But let's see. Yours. I know that, for example, for the DAO, I tried decompiling it. I don't know how the new version handles it, but it had some problems because it was too complex.
Yeah.
But let's see this one. All right. It does. So it has a few storages here, right? It has set owner function. Then it has some functions that are getters, right? And like I don't know the signature of this, so I just say just unknown. Right, so there is one getter for something called DAO, so another one for next, and I already can see that there is a bug here, but never mind.
Well,
like
next is probably like, okay, let's do the next next split attack.
Yeah, but I see right now that I have a bug because then it should figure out that this storage is called next. Never mind. So there is some counter, right? And then you can see the function. So there is this function that requires caller to be the admin. I assume storage 0 is the admin, right? Yeah. Then it sets, it calls, checks storage 7. I don't know what is storage 7, but checks its balance, and then calls storage 2.0 with split DAO and returns. Then there is the set DAO, which I guess changes the address of the DAO. Okay, so here we have a function that checks the owner. Transfer function, that's quite unusual. That's quite regular, right? So it transfers, it forwards the call to the, I guess this was the DAO. And here we have something. Okay, this sets some kind of a storage. CD68, that's parameter, call parameter. So this would be the third, like we have 3 parameters here probably, and this is the third parameter from the function call. This is the second. This is the 4th or 5th. So this one sets this storages to whatever was called in the function, and then checks the balance and again calls speed DAO, right? With this parameter from here. Then there is vote that forwards this to the DAO. There is curator. There is fallback. That's it. Like this is all there is. There is nothing more to.
There's a second DAO contract, DAO hacker contract that he forwards it to. So because there's 2 contracts interacting.
Okay, do you have the link to the second one?
Oh no, I didn't. I was too excited to see what but
okay.
It's this is the contract that voted in the DAO and would call split DAO, and then when it would recirculate the ether from one contract to another, and then this contract would do some stuff, and then send, and then the DAO tokens would leave this contract and go into this contract, and they also like sent ether to the reward DAO contract for some reason, which they didn't need to do. But
okay. So
yeah.
Okay, let's not waste more time, sir. Although I saw something on blocks here. This is not a contract.
Address, yeah.
Okay, never mind. So, but you can see essentially like this is this is quite awesome that you can see almost sources instantly, and sometimes it has problems. So some of opcodes I still didn't implement, and there are some tiny quirks here and there. But essentially, for any contract, you can see the sources. And the other cool thing is that I want this to be open source. So like it's not like we have only we only have Etherscan that we have to link people to, but even if the sources are sometimes kind of a little bit buggy, then like we can have that on open source explorers to just to just see. Oh, one more. One more thing. This method that I'm using, symbolic execution, it's like ideologically, it's much closer to actually formal verification of contracts than regular decompilers. So what I end up with is kind of these structures that are super easy to analyze, looking for flows in contracts, and that's quite awesome. So I will give you an example. This is like 10 lines of code that I wrote between the meetings on DevCon. So one thing that I have on the main page is just like, imagine that you have a Google and you can, for any piece of code, you can see how contracts implement that in how many ways, right? So I can just type in, oh, show me all the transfer functions from all the contracts, and I can see how contracts do that, and just try to play with that. But that's that's just one thing. But I'm actually using that, for example, if I want to find a new some other stuff that I want to decompile, or some certain pattern in programs, I can actually check that. So when I'm technically, for example, loops, how to handle loops, so all the loops, how people write loops, and what kinds of loops people have in their contracts, right? So that's one thing, but that's still not super exciting. But the second thing I called self-destruct piñata, and this is, I just went through contracts, and that was some time ago. Like I think, yeah, during DevCon, I checked some of the contracts, and I said, all right, find me all the contracts that have self-destruct, and all the ones that have it, that don't check who calls the contract. So if you have a self-destruct here, no if on the way checked, for the value of the caller. So that means anyone can call it, right? So I found some of the contracts. And then, since I know like all the ifs, I can automatically check what are the conditions. Are they met? Like, what needs to happen for them to be met, right? So this is storage 0 has to not be 0, and it checks, all right, storage 0 is not 0, so this could be called right now. This, for example, contract compares timestamp to some unlock time. So unlock time right now is 152.
Wait, are you sharing? You're not sharing your screen.
Oh, sorry. Oh, no. Okay, thank you. Thanks for letting me know. Okay, I was showing the whole website, and I have to do it again. Okay. Okay. You can see on the screen right now?
Yeah.
Yeah, okay. Okay, so I was showing first the transfer functions, right? So like I have all kinds of transfer functions here, and then I have this thing called self-destruct piñata. So for example, like for any function, for any contract, and I decompiled like, I think a 1.5 million by now, or something around that number, and I just, it's super fast, so I can do that very fast. Yeah, I can just see all the contracts that have self-destruct here, and just on the way they don't check for anything, right? So for example, for this one, self-destruct to the owner, and it compares timestamp with the unlock time, and unlock time is this number here, so it's 152. Now it's 154. So essentially, like, if you went on, you could kill this contract right now, and anyone can do that. And it's there. It has 500 fines, so like, I guess no one bothered.
Yeah.
But this is not the best one. Like some other ones, perhaps in some cases the condition hasn't been met. But I absolutely love this one. This is a contract that has one admin function, and I checked. Actually, it has public open sources on Etherscan, and it's there, right? And it has one self-destruct that sends money to the admin, and it has like $600, or I guess 3 or 4 on the account. So the admin can, and I checked it. It's some kind of a game. So I think someone may be making some kind of a scam there. And like the reason I didn't kill it, because if it grows to a higher amount, I will absolutely kill it, so people don't. It seems no one else is checking that, or at least no one else is killing the contract automatically. That could be killed as a, I don't know, public service or something like that. So
yeah, no, I mean,
so just the fact that this thing is, yeah.
We had to do this on the fly with the White Hat group when the parity multisig hack was happening. The first one where we found that anyone could init the parity multisigs, right? And so we had like a team of 30 people basically build a very one task version of this that would just search the EVM for this pattern of bytecodes, right? That and trying to find all the parity multisigs that had this pattern in it. So
yeah, yeah.
now with this tool, we can just do it with one button.
Yeah, and that's so the cool thing is not just it doesn't. This function you could find by simple pattern matching, right? But with more advanced, it actually checks all the logic, so you can already see. And it looks simple once you decompile it, but like it can be sometimes quite convoluted and quite difficult to find out. So like if no one is ahead of I'm thinking of adding also withdrawal bonanza, where I just find all the contracts that have open withdrawals for anyone, and I wonder if there is anything there. Out of pure curiosity, perhaps some contracts have it, and yeah. So that's yeah, that's how it is, and yeah.
That's so cool.
I know that.
Have you talked to Andrew from POA Block Scout about
just give me a second.
Because it would be really interesting to see this as you know, a lot of contracts aren't verified on there, but if you could just, you know, click this button and have this there, that would be really interesting, you know.
Yeah, absolutely. That's my goal. So like we spoke after the previous call about the whole about the token metadata, and we definitely need to schedule another call to talk about this. Like I had so much work because I want to polish more details of that. So you know, it's tough balancing between calling and doing that. But like yeah, definitely, I think we'll schedule a call, and I hope POA or Bloxy.info or whoever like wants to like add this there. That would be awesome. And you know, that's my kind of dream to just, you know, give that to the community and see what happens, because
Yeah.
like it's nice to have you.
So this is a pure labor of love. There's no monetization or anything.
Yeah, it's, you know, I've been in the blockchain community for 6 years, right? And I've been doing startups for 15 years. So right now I kind of I want to just take a break from that and just do, yeah, like you said, labor of love, and also in like pure interest, and just you know, I want to see what's possible there, and just want to tackle the challenge, right? So this the idea is to perhaps not monetize it, but I would love more people to find out about the website, right? So not just okay, open source it and someone will use it and then no one will know that it's from here. So I would really want people to figure out like to also like go to the website and check it out. But yeah, essentially that's the goal. It's simple.
That's amazing.
There are so many people that are doing kind of almost volunteer work like you, right, with Giveth, and of course you like there are grants. Like I've been using open source for my whole life. You know, using some work that someone did in their spare time. So perhaps I should just bunch it all together and pay back to the community in one, 2 or 3 months working, and just give back to the community, and that's it. And also, like, it's, you know, wanting to see the world burn, I would say, just wanting to see, you know, this open source solution beating all the closed source solutions that may be there, and just, you know, messing with the business models of some other people that wanted to have that kind of stuff, you know, like, you know, chaotic positive kind of thing.
Yeah.
So that's the goal. Yeah. That's
amazing. Well, I mean, it looks really polished. I hope we can get it out and get some other people looking at it and contributing. We'll see what we can do.
Yeah, keep the fingers crossed so I can deliver good quality source code, because right now it's a 1 month or a month and a half of hacking. So
yeah.
So I also one challenge that I made a pact with some people on the rave party on DEF CON that will use emoji in one of the function signatures in our code. So it will have emoji in at least one function, and like that's for sure. Like I think for testing the pray emoji or something like that. Okay, never mind.
No, that's awesome. That's awesome.
We need we need more emojis in our source code. That's
100%.
Awesome.
100%. Well, it's so boring with just transfer and all that shit. Come on.
With smart contracts. I actually did a token once that had emoji in the symbol name. That's nice to see which systems can process emoji when the contract has an emoji in the token name. That's
Yeah, now we're talking.
Yeah.
Well, cool, man. I mean, this is great. Where can people, if people want to contribute, where do they go?
Well, go to the website first. There is my email there, and just let me know, right? So, that's I'm kind of not yet ready to publish the sources, but just email me and let me know, like, if you found any bugs, like that will be super useful. If you don't like something that prevents you, that makes you feel, all right, this is not yet good enough, or I cannot understand something. Like some people approached me and said, oh, like this contract, like it's kind of decompiled, but I still don't know what's going on, right? Then we worked through it, and that helps me to figure out how to deliver the sources better, right? And you know, like yeah, and just, you know, tweet or share, and just, you know, I would really want some people to start using the site and just get the word out there. But reach out above all. And yeah, I'm in Europe right now also, and January I'm going to Silicon Valley. So just, you know, let me know if there are any meetups open or anything, and I would love to talk.
Hey, if you want to escape the cold Europe, man, come down to Thailand and hang out.
Thailand. I was thinking, yeah, it's yeah, perhaps a few days. Cool.
Okay.
I will think about it.
Yeah, definitely consider it. I'm going to be there from basically the Singapore on the 7th until the 19th of January, until Arakan.
I need something in December though, like December invitations from any meetups, South Europe, hopefully this time zone, but any time zone will do. Like I'm there. Like I need that so much.
Nice. Yeah,
Cool.
man, time zones are so hard. But yeah, okay, cool, dude. Thank you so much for showing off your decompiler and making all this work. I mean, I know it's a lot of work to put that together.
It's a lot of work. It's a lot of work. Just kidding. Yeah. Okay. Thanks, man.
Yep. See you around, buddy.
Bye. Bye. Okay. Do we